Hi. So today I wanted to record some sort of tutorial on how you can actually create your own Cube um, multiplayer game, but unfortunately for some reason I can't link two words together. So instead of the full tutorial, I'm just gonna show you the way how you can do it without coding alone or something like that. And I will also provide the sample project, so you can just take a look on it and figure out how you can modify it for your needs yourself. So first of all, let's talk about the general setup. If you're making a multiplayer game, you usually need a setup of two parts. First of all, you need a game client, which is in our case is our Cube game, and then you need a server part, which um, which we have to come up with something because Cube doesn't have um, any capacity to run the server side. So for using server for the server, I'm gonna be using something which is called Node.js. Node.js is basically the execution environment which allows you to run JavaScript on your backend. And on your backend, I mean on your operation system, on Windows, on Linux, on like whatever you want. You can download Node.js from its official site here, and I actually encourage you to install the version which I happen to have here, which is 12.80.2. I will leave a link in the description. So, um, first of all, uh, we're talking about the project right now, and let's talk about the limitations. First of all, it's not, even though it has a client server, it's not really client server architecture because all the logic still runs on the client side, and client will only send its data to server, and then it will receive the data of our players from from the server basically. Yeah, that's the limitation, and this is really important to understand this because this approach makes it really easier to other people to cheat in your game, which you should consider if implementing this. Also, the other thing is that if you're familiar with RESTful APIs, you know that you can use different type of calls like get call, post call, I don't know, like put call or something like that, like quite a lot of them. But I mean, delete call also, like for the most useful. So, but with Cube, we are very limited. First of all, we are only limited to one technology which we can use, which is HTTP. HTTP, Hypertext Transfer Protocol, is what we are going to be using since it's the only built-in tool which we have in Cube. And here we also limited to only get calls, so no post calls, no other calls, which means that we are not able to send any documents, any data using bodies. So what we're going to be doing instead, we're going to be using the how is it called properly? The query parameters. So what is query parameters? Here I have a really simple setup. This is our server. You won't believe it. This is how you code like a server in Node.js. And it only have one endpoint, which is like the root endpoint. And if I run it, let's modify it a bit. Let's just, instead of a query for now, let's just send something like hello from Express, like that. And then we just run the server. Also, if you're new to Node.js or if you don't know like anything about it, I strongly encourage you to look up for some tutorials on how it's set up, how it works, because I mean it's really a useful tool. It's amazing framework, and also we are using Express here, which is a web server from Node.js. So if you're interested in how this like backend setup is working, just check some other tutorials. Yeah. So now if we call, now we just run our server, it says it listens on port 3000, and now if we call localhost 3000, we will just see this message, hello from Express. This is how we get data from our server. So instead of this like hello from Express, we can put some data which actually makes sense, for example, like player position is 1, X position 1, Y position is 2, Z position is 3, or something like that. And if we just call our server here, it will return us these positions. So that's as basic as it could be. This is how we get the data. The second question is how we send the data. And for that, we're using something which is called query parameters. To add a query parameter, you just put something into, you just put a question mark to URL, and then you just add the query parameter name and then value. And then you just put and you can put like your second parameter and the second value. And you can access these query parameters in Express using the line which I have here, which is basically resend, which is basically req query. So if we just send this request again, and if I run the server, yeah, so we will get our query parameters. That way I can send my data from client to server. So how do you do it in in CopperCube? I have already done a short action which is called test call. So here I have the URL, and then I have a response function. And if I send something like, let's say, key1 equals ASD, and if I set it, ideally I would receive some sort of response with the like this, the same keys. And as you can see, I get it. So if I add something else there, let's say, oh no, it's incorrect window. Let's say key and then add ASD something else. And if I call it again, I just get the second key. So basically that's how you just send your data to the server. There, it's great. So we can send the data, we can receive the data, and this is probably enough if you're doing some sort of a puzzle game or maybe some sort of like slow-paced tactic games or something like that. But unfortunately, for a real-time game, it wouldn't be enough because um, unfortunately we can't just do it every second. So as you know, usually CopperCube runs at 60 something frames per second, and the performance of this do HTTP request command, it's not really that great. So I mean, it's good enough to me, but it's not that great. And you won't be able to send and receive the response on the same frame. It's just not possible. So we'll be doing some trick which a lot of like bigger bigger frameworks, a lot of bigger companies do. We will limit our calls to 50 calls per second. This way we will sort of emulate something which is called 20 Hz server. Well, at least I believe if I'm doing math correctly, it will be like it means that 20 Hz server means that we are going with 50 calls per second. And with that approach, we will get a better performance, but we have an issue here. And the issue is that if, for example, let's say we have some character in Bush, and okay, we have like this really nice person here, and if it moves to right, let's say with time, we will only receive its position at the point we send the request. So we will get the position every 50 milliseconds. Oh, how much? Yeah, 50 milliseconds. So it will appear at this x1 here, then it will appear at this x2 here, and it will appear in this x3 here. So what we are going to be implementing is something called linear interpolation, which sounds much more complex than it is. Basically, the idea is the idea is based on something which you learn in your first physics class at school. If your character moves at the constant speed and you know the distance and then you also know the time, you can calculate the position of this movement at any time. So let's say we calculating like it's if like we need it's not at 50 milliseconds here, but at maybe 20. What we're gonna do? Um, we just do x2 minus x1. We then how is it called? I forgot the word. So basically, we just do like x2 minus x1, and then we just do this like mathematical action, which I don't remember the English name of, and then we just multiply this result by 20. Yeah, I believe this is work, and that's how we find the x position, like x1 dash 2 position of our entity in each point. But this sounds great, but what but it also comes with some sort of trade-off. It means that we are not going to show our character at the real time, but instead we will be rendering it how he was or she was or they was at some point in the past, which means that we are not showing there's the brush. Okay, so we are not showing where the character is now. Instead, uh, we will just subtract some time, let's say 100 milliseconds, and we will call this rendering time. And then we will render the character position in this spot. Basically, this is something that a lot of games do, and I understand that this description is pretty bad. I would say, I guess it's pretty bad, and it's not clear. But you can also check some of our videos on this, I guess, because there are a lot of people there who are much better in describing such things than me. So basically, this is the only trick from like the big games. Other than that, we're not gonna be doing any magic. Also regarding the data types, so this way, with linear interpolation and stuff like that, we can show player positions, we can calculate player positions, but they're not only the positions which we need to send. For example, so I mean not only the position, but there are some other things which we need to sort of like deliver to our server, and this other category I just call events. So event is, for example, when you fire a gun, or when you're like, I don't know, then you jump or something. Jump is a bad example because it's also position. Fire a gun, pick up an item or something like that. This is event. So in this case, I'm not doing any interpolations or something like that. I'm just sending the event. As soon as this event reaches the other player, it's executed on the other player side. I mean, I hope this description make any sense. Maybe at some point I'll just write the scenario and sort of like create the whole video like the normal video, but I hope for now it at least makes sense. So regarding the test project I was talking before, let me just show you first how it looks. Let's just close all the windows which I don't need. Is it? I don't know. Let's just also close this one. And let's go to corporate cube and then multiplayer desktop. And I also already have a client and server set up. So if you're running this for the first time, I won't include node modules. What you need to do is you need to open CMD and run npm install first. This is described in the README file here. So let's just run our server really quick. We're gonna be using node index for this. And I also will open the project, open recent file client. Yeah. And here's the test project. Let's talk a bit about how it's set up. So pretty basic once again. What is that? Okay, doesn't matter. Yeah, okay. So yeah, so basically what we have here, this node is just your basic skybox. It doesn't have any behaviors. This is your plane, which is basic plane, something to collide with. Then you have your local player here. This is a camera which I created by just creating the camera and then first person shooter camera. This camera actually have some custom behaviors. Let's go really quickly through them. This is the one which comes with a camera. This is the default one. It's to move, basically to move. Then this is the collision, the yellow sphere outside it. Uh, this stays for shoot. I will come back to it later. And these two are my custom behaviors: handle network and also update network entities. I will talk about them a bit later. Then we also have a network player. Network player is where it is actually. So it's okay. It's under the. I put it under. I'm not sure where it is, or it's just in position. Let's just check. Okay, because yeah, so here it is. It's on the upper side. This is our guy with a gun in his hand, and this will represent all the network players which we have. So not the local player which you play, but the other guys. And it's invisible because I'm making a copy of this every time someone connects. And it also has like zero behaviors, I think. Well, at least I think it has. No, it has an actor behavior because I'm not sure why it has. Okay, yes, because I wanted to have action on hit, so you can shoot the guy. And I have some simple HUD here, which is just the crosshair and also this HP here. So that's it. Let me quickly show how it works. So I'm gonna run one instance in the desktop mod and the other one I'm gonna run in the browser by connecting to my local host. I'm doing this because it's actually not possible to run both of them at the same time in the desktop view because the one of them which is not focused won't render and it actually won't work. It actually won't run. So basically, as you can see, I'm running with one guy and the second, and this guy is shown on the other on WebGL version as he runs. And if you shoot, it sort of like shows this flash for a really short time, and then if you shoot right in the WebGL guy, you can see that HP on the left side, it just becomes like less. So now it's only 50. And if we can find the right guy where it is, I'm not sure where he hide. Okay, so I disconnected. Sorry, I just disconnected. That's why he disappeared. So, and if I just shoot the, where are you? Is something broken? Okay, here he is. If I shoot him, as you can see, like properly, it's not properly updated on the desktop side because I'm just out of focus. And if I just came back into the focus, you can see that all HP are gone for our like desktop guy. So this is basically the project. This is basically what I'm attaching to the video. Let's talk a bit about how it works, and I think that would be it for today. So, 2 Points Campus. Oh, nice. Okay, I will definitely buy it. Um, so first of all, these two behaviors I was talking about, these two which are attached to our local player. First of all, the handle network. This is the main one. Let's quickly go through it. First, I have set up some polyfill functions. If you don't know what polyfill is basically the implementation of default functions for the previous versions. Since Coppercoop is actually using some really old JavaScript language version, it doesn't have a lot of useful functions which you have in your modern browser. For example, it doesn't have JSON and it doesn't have like object keys function, which I will use later. What JSON is? JSON is really important because um, one can't just send the data over network. The only way, basically not the only, but the most convenient way of sending data of the network if you send it via strings. So something like that is good. Something like that probably won't work. And what JSON object does in JavaScript, it just allows you to so-called, and now there is a guy with a drill. It allows you to serialize and deserialize object. So this means that if you have some sort of object, you can run JSON stringify, and it will get you a string from that object. If you do, I so hope it's not that loud. And if you do the opposite thing, you just receive your object back. So now this is an object. And the idea is that you just stringify your data, you send it over the internet, and on server side you just parse it back, so you get your object back. This is the polyfill for JSON. This is a polyfill for setTimeout function. SetTimeout function is actually also not a part of JavaScript. SetTimeout function is a part of browser API. So for this reason, CopperCube also doesn't have it. And this is a polyfill for it. And then object keys is something which just allows you to get the access to your keys of your object. So if I just run object keys, I'll just get the keys X and Y. Yeah. Okay. So the next part is Visa key codes. These are some constants for player animation, because if you're using a third person camera, you actually have some animations on your node, but I'm using a first person camera, which means I need to somehow specify what currently like my player is doing, because I don't have when I'm looking at as a from the first person perspective, there is no model. And yeah, so you got the idea, I guess. Then the next thing is my host. I'm getting host from reading file contents of the host file. If you just go to the client folder here, you will find this host file, and it contains the API, I mean the IP of your machine. If you're running everything on the same machine, you can just put localhost here. If you're running it over Wi-Fi or something like that, you can just put like your IP. If you don't know how to get it, basically you just go to Wi-Fi and then you just click properties, and here you will have your IP address here. If you're sort of using the internet, if you wanna exchange data from the internet, you can just Google and then just go to Google and then Google for my IP and just open the first site. It will show you your IP. I guess you already know it. And also, I'm getting different variables for WebGL target and for the desktop. This is done because I'm actually not targeting WebGL. This is only done for compatibility. Yeah. Yeah, the next thing is our player ID. Each time the new player connects to the server, it gets a new ID. It's just a number from 0 to the end of int. Then I have a player HP as a separate variable. You can obviously use the default built-in HP, but I'm just having it here for simplicity. I have a current animation, which basically I don't think it's actually used. No, it's not used. I'm not sure why I have it. I will just remove it for now. And then I have move key pressed. This is the array which contains the object, which contains all so it contains it contains basically 4 booleans for each W, A, D, and S keys. If I'm changing it here on in event, if the key is pressed, it will be set to true. If key is not unpressed, if it's released, I mean, it will set the value to false. Using this array, I'm actually checking if one of these keys is pressed, then animation should be moved. If none of this pressed, the animation should be idle, which is just stay. Yeah, this is also worker. Oh no, enemies. Why is it here? Okay, enemies. It's something that I'm not using for now. It's all over. I'm not sure why is it here, because I thought I removed everything related to enemies, because it's not, basically it's not completed yet. So let me just also remove it from here. So yeah, oh no, I just leave it basically. Yeah, that's it. It's just it's not used right now because this is something that is not complete right now. So this is for handling the enemies and the NPC logic, which I never did. And this is there. This is basically this. The whole block is a workaround to make this thing work on WebGL. It gets platform, and if it's WebGL, it adds all the properties I mentioned here to global Windows object. This way you can access it from any script. If you're using the desktop target, if you define the variable like that, it's available on every behavior you use everywhere. But if you use WebGL, it's only available in the script it's defined. So that way I make it accessible from everywhere. Then this one is current state is a state of your network. Here is a simple description of what state stays for what, but I will just describe it a bit later. Active IDs is IDs of your active players. Game states is the snapshots of your game. So this is something related to the okay, it won't. I guess it won't. Something related to this like thing, this interpolation. So it stores the world data from different times. So one would be like minus 50 milliseconds, one from minus 100. Once again, it's just sorry, I just can't like explain it better. So these are just game states, which are states of the game world in different times at different times. Then I have events to send. This collection just has all the events which should be sent during the next request to the server. So if a player, for example, shoots a gun, this event is added to this list, and then it sends. When it sends, and the list is cleared again. So I also change the default. I also disable the close on escape function, because every time player presses escape, I need to call the disconnect endpoint, and this allows me to disconnect the players. So basically, if I just press escape, the player not only not only the game turns off, but also the player gets disconnected. So other players can't see him anymore, or she, or there. And also, for the WebGL target, I'm also sending the alert that you are disconnected. So it works for both desktop and WebGL. Once again, it's just for compatibility reasons, and I'm strongly encourage you not to use this approach for WebGL, because there is a better approach. Yeah. So here our behavior actually starts. This is on animate function, and here you have this construction to run it only each 50 milliseconds. So we are not running it only on each frame. We are only running it about like 20 times a second. And then I have a switch which defines logic for different game states. By default, the game state is 0, and 0 is init, initial state. What it does in this state, it's only run once. So the very first thing which it does is just change the state to 1. Then it does the HTTP request call to endpoint which is called getID. Let me just switch to the server side. This is the server side. This is a server to this client. We also have a getID endpoint here, and also notice that I'm using the newer ES like 6. I'm not sure what ES version is 9, but the newer syntax. So I'm using this like arrow function here, not the regular function, and they're also not the same. But yeah, so then user calls this get ID. It doesn't have any parameters or something like that. So what it does, it just returns us the ID, and ID is basically a number next ID. Each time the new player connects and calls get ID, I just increment it by 1, so every new player receives the second ID. Also, this ID is added to active IDs array. This way I can control which IDs are active from the server, and then I can also compare them to to local active IDs, let's say it like that, which I have inside the behavior here. So I also have active IDs. And if they're different, it means that either new player connected or someone has disconnected, and you need to take some actions on this. Yeah, so basically what it does, it just returns you a new ID. Yeah, and that's it. In the callback function, you can see that what it does, it parses the data using JSON parse data, and then it assigns the local player ID. It also prints that it got the new ID. Yeah, so on the first loop, it just goes to this current state 0, it changes to 1, and the second loop, it just it stops on this one. And what it does, it just waits until player ID is not null, basically. So it checks if it's not null, it just sets the current state to 2. Current state 2 is to get our player's data. We can once again check the endpoint really quick. It's like this one, get players, and it only gets the active IDs. So all the active IDs which are stored on the server will be sent to a player. And for each of this ID, I will create a new network player. By that I mean that I will find a node which is called network player, which is this fly-on guy without any behaviors. There is it, where it is, here's this guy. And it will create a copy of it. It will put it, I believe at least it will put it in the default coordinates, but maybe not. Maybe it just, yeah, it doesn't put it to any coordinate. It will just make it visible, and it changes the entity name to network player plus player ID. Player ID not the local player ID, but the one which is in the list of active IDs. So um, the one from the list. Yeah, so that way I create a network player for all active IDs which I have on server. So basically for every player which are currently connected. And I'm also checking for active IDs length. It should be greater than 0 because it's even if you are the only one, if you are the only player on the server, this list will have your ID there. So that way I'm checking that I actually received this data. And then it changes to the latest stage, which is state 4. And in this state, this is the main state. This is where you send the data. What happens here, it finds your local player node, which is your local player, which is a camera node, basically, this one. Yeah, it gets its position, gets its rotation, and then it puts everything to outcoming data. So it puts player ID, position, rotation, events to send, and also it puts the animation. Also notice that I'm using really short names here. This is done on purpose because this URL which you're using for your call, it might be limited actually in characters. I believe currently with expressing Node.js, you got like 8 kilobytes maximum length, which is quite a lot. 8 kilobytes basically means that you can use around like 8,000 characters if you only using ASCII characters. But if you have a lot of entities, this still could be an issue, and so I'm trying to put like the shortest name that I can use. So what also to notice here, I have like minus 14 on the camera because the the position of like network player and the camera, they're actually a little bit different. As you can see now, the camera is on plus 15 on y-axis, even though it seems like it's on the ground, but it's actually up on the ground. And the regular entity, like I mean the regular this guy with this like bald dude module, it stays on the ground, so his position is just 0. So that way um, I just put him on the on the right spot. If you don't put it here, he will be flying in the air. All the network players will be flying in the air. And then I'm sending this network data using update endpoint, and data is our outcoming data. So it's stringified also, as you can see. So it's sent as a string. Let's just check a server for what is done here. So there is this update function. It's also pretty simple. I parse all the data. I put data to game objects. Game objects is basically a list of all your players, but it's not an array, it's an object instead. So you have a key, your player ID is a key, and then you have the corresponding data like ID. Once again, it's mentioned here, once again, just for convenience, position, rotation, and also animation. You add this, so I'll get back to events a little bit later. Let's just discuss like the moving part first, and then I will get back to events. And yeah, send active game objects dot id. So yeah, and then as I update all game objects that way, I'm just sending the game objects data back to the client. And on the client side, there is this function which is a callback function, and as you receive the data from the server, it's parsed once again because it's what is required to do. Then I find the difference between active IDs from the server and local active IDs. In case some player is added, I create a new network player. In case player is removed, I remove network player. And if there is actually a difference, I am also updating the active IDs on the client side, so they're the same as the server. Then I put this data regarding the entities to game state, which we were discussing before, with like these states of the world at different times. And I also put a timestamp then when I get, so at what point I get this sort of like response. This is actually not the best way to do it. It should be handled a little bit different. So I guess everything should be synchronized to server, and you should get like the state um, from the server. But I'm getting it from the client. On the client, it's easier. And yeah, this one is also related to events, so I'll just keep it for now. And basically, this is more or less everything related to moving. We can just go to update network entities really quick because the video is already 40 minutes long, which is much longer than I expected. So first of all, interpolation time. This is a parameter which I'm using here. Interpolation time is how far in the future you're moving basically back. So this will be like minus 300. So I'm rendering a scene as it was 300 milliseconds before the current time. You can actually send it to 100 or 50. It will still work probably, but yeah, 100 I think is a good number actually. Then it gets all the game states. I call it snapshots here. I'm not sure why. It's just I was just copying it, as I mentioned. I was just copying it from other games and from the other game, and they were called snapshots there, I guess. So it's just stays snapshots. So these are game states also. So then again, we get a current date. I'm calculating the rendering time by subtracting interpolation time from current time. Then I find the next snapshot. Next snapshot is basically the first snapshot which comes after the rendering time. So in this case, on our picture, it's a mess right now. If we are here, the next snapshot will be this one. Yeah, and the previous snapshot will be this one, just to to mention. So I'm finding this next and previous snapshot. Basically, these are two snapshots between which our current rendering time is. So let's put it like that. But I mean, it's once again, it's just pretty like pretty bad description. And then also I'm slicing the snapshots array by the previous snapshot because I don't want to store all the states of all times, and if I don't need it anymore, I just remove it. I just remove them. And now I'm doing this interpolation I was talking about. So for every game object, if if ID is not a player ID and not local player ID, so for all the remote players, I'm getting the previous snapshot game object ID. So I'm just getting the previous position and rotation and animation object, and then I calculate this its position or rotation using this linear interpolation function, and also degrees, the one for degrees, and I'm setting the position, rotation, and animation from the game state. I hope it makes sense. I don't think it is, but I hope it is. So also notice that there are different functions for distance and for the degrees, because for degrees, if you use this one, you will sometimes get not the correct rotation but the rotation in the opposite direction. It should always find the shortest angle. And if you're using this one, it will sometimes just rotate the other way. And also, I'm not interpolating the distance or something like that. I'm just doing it for every coordinate. So for X, for Y, and for Z. Yeah, it's simpler to just to do that way without like vectors or something like that. Basically, this is how you position everything. And the only very last thing which is left is the event. So if you noticed, each time let's say I'm firing a gun, there is some event, there is something happens. Basically, you can like, let's just run it again. So Control F10, and I will run another instance in browser again. So yeah, I don't need. Let's just go localhost. So if where is the browser? Yeah, my mouse. So if I shoot the gun, there's this little like flash which appears, and also if I shoot the other guy, HP go lower. This is done by the events, and it's implemented pretty much in the following way. So on this handle network function, I have this array which just says events to send. Here it is. And each time the event is created, I'm just creating sort of an object. Not sort of, I just create an object and I put inside the event to send. So let's go to our scene and let's go to local player. Here is the event which is called when key is pressed do something, and there is the execute JavaScript, and here I have this code is for a flash to appear and then to disappear. It also have a different slightly different syntax for WebGL and for desktop, but the main thing is what I'm doing here is I'm calling this add short event. So it's called, and then on inside the function, what I do, I just add event to this array. It has event ID 1, so for each event, for example, you have a hit event, its ID would be 0. For short event, it will be 1. If you pick up an item, it will be event 2. If like doors open, it will be event 3, and so on. So for each unique event which happens in your game, you should have like its own ID. And then it has a parameter here. So here I have a player ID. It means that that way I can identify which player actually shoot the gun. So if I have multiple network players, only one of them will actually appear with this muzzle flash on the gun, other ones won't. And also I have a hit event. It's done the same way on the there is it on the network player. I have the sector behavior, and here is on shoot. I'm just calling JavaScript, which just calls at hit event. It also sends the player node. So that way I also get the name, then I just hit ID, and hit ID is basically the ID of the network player which is hit by the gun. Yeah, so that way I can, if there are multiple network players, I can understand which one was hit. And then inside this update function, this big update function where I put the game states, I execute events. So for every new event which is received from the server, I get its ID, and depending on the ID, I act differently. So for example, 0 is our hit event. So I just find the if this hit ID is my local player ID. So if someone shoots me, then my HP gets less by 10, and I set the text for the um, for this like little hood here to the actual value. And then I have this second event, which has event one, and it's once again like a little differently works differently for WebGL and not for WebGL. But basically, what it does, it just finds the network gun flash node and it shows it for a couple of milliseconds. So basically, that's it. So um, I think yeah. Also, the very last thing which I would like to mention is that events to send this events to send queue, I really have I don't have like the one queue for all events. Instead, I have this like object which allows me to identify which event I should send to whom, basically. And as you can see here, I just filter when update is called, I filter all my active IDs by my player ID, and for each player which is not my local player, so not the one which sent the update request, I put all the events into their queue. So that way I'm not sending my events back to me. So I think you got the idea. For these ones, I mean, it's actually even doesn't. It could be done like you can use one queue because it will don't do anything. It will just won't find like hit ID if it's the same ID as you. So, but I mean, this is a more convenient way to handle events from multiple players. Also, this is done because that way, because usually it's the server who initiates the request, and in other case it's a client. So it's a bit how you have to do it in CopperCube. Yeah, but I mean, that's more or less it. And yeah, sorry I didn't actually come up with this real tutorial, but I hope this code makes sense. I will put the code in the description. It will be somewhere on Google Drive. And also please free to ask questions if you have any. And it actually would be more convenient if you just create the topic on the CopperCube forum, because I'm usually just checking it more often than YouTube comments. And yeah, I think that's it for today. Hope it makes sense.